Early in his presidency in 2021, President Joe Biden first set the goal of reaching 100% clean or carbon-free electricity for the United States by 2035. The question is, can we do that? In 2025, the US power grid experienced a historic surge, with 53 gigawatts of new capacity added, the largest single-year expansion since 2002. But that milestone may soon be surpassed again. Looking ahead to 2026, power plant developers and operators are planning an even more ambitious build-out, 86 gigawatts of new utility-scale generating capacity, a whopping 60% increase over the previous year. At the center of this transformation is solar energy. Solar alone is expected to account for 51% of new capacity additions in 2026, which is enough to power at least 32 million homes, or an equal of 86 million people in total. This growth is not evenly distributed. More than half of the new solar capacity will be concentrated in just 4 states. Texas leads by a wide margin, accounting for 40% of planned additions. Arizona, California, and Michigan each add another 5 to 6%. These states are becoming central hubs in the nation's clean energy transition. Battery storage is also playing a rapidly expanding role, making up 28% of planned capacity additions in 2026. These systems are critical for storing excess energy and stabilizing the grid. Once again, a few states dominate. Texas alone represents 53% of planned battery storage capacity, or 12.9 gigawatts. California and Arizona follow with 14 and 13 respectively. Together, these 3 states account for about 80% of all new battery storage capacity. Wind energy, while still significant, makes up a smaller portion of the upcoming expansion at 14%. So, why is energy demand increasing right now after 15 years of stagnation? This resurgence signals a critical transition to the electrification of energy use, due to the high reliance on electricity as energy input by some of the most dynamic drivers of current global economies, such as artificial intelligence, data centers, and advanced manufacturing. In fact, as recent as 2025, only about 20% of the energy usage comes from the electricity transmitted through the power grid, a huge potential for more electrification to come in the future. As we enter Industrial Revolution 4.0, AI and data centers are driving a huge demand for electricity due to the power-hungry nature of devices such as GPUs and CPUs. As we can see from this chart, data centers' electricity demand increased 6-fold from 2018 to 2026 and is set to double again by the end of this decade. In the United States, it is estimated that half of the total increase is driven by the rapid expansion of data centers. As energy demand grows and sustainability is more stressed, renewable energy is playing a bigger and bigger role in bridging the gap between the two pressing challenges. So, can we achieve 100% clean energy by 2035? In 2026, the US power grid has about 45% coming from clean energy sources, with nuclear energy accounting for the largest share, followed by wind, hydro, and solar. There is still a significant 55% of electricity generation sources yet to be replaced by clean energy. To make clean energy mainstream, we have to make clean energy cheap. LCOE, levelized cost of energy, is a way to measure the cost of generating electricity from a power source over its entire lifetime, average per unit of electricity. Basically, it is a matrix to measure the cost of an electricity source. Hydro has been saturated in the US since 1975, hence it is out of the equation. As the chart shows, solar and wind are now the cheapest electricity sources, slightly higher than a natural gas plant, with an LCOE of about 4.7 cents per kilowatt hour. Nuclear is about twice as expensive as solar and wind, making it even less attractive on top of its risk. Lastly, the cost of batteries still remains high, making it a significant hurdle to achieve the 100% clean energy goal. So, if solar panels and wind turbines are so cheap now, why don't we deploy more? Well, when considering energy options, we must also factor in their stability and abundance. Not everywhere in the United States has good sunlight. For example, the Midwest region. Not everywhere in the United States has good wind. For example, the Southeast US. Hydropower and geothermal are even more limited. Large-scale nuclear power plants have been built only at a super slow rate since 1990 due to their high cost and long duration of construction. Even if a state or region relies on entirely renewables, there's still a slight chance that the weather doesn't go in their favor, leading to a power outage. Even though battery can help solve this problem, it's expensive. The LCOE for batteries is even higher than nuclear, which may not be economically viable to install at a large scale currently. Another challenge with solar energy is that its peak supply does not align with peak electricity demand in the United States. As shown in the chart, solar generation peaks around 12:30 p.m., then steadily declines to nearly zero by about 6 p.m. In contrast, electricity demand continues to rise throughout the day, peaking around 6:30 p.m., a time when businesses are still operating and people are returning home. This difference in our electricity demand can have a peak-to-peak ratio of up to 2.5. Hence, solar alone does not help meet the higher daytime energy demand. In fact, it makes the curve steeper. The fundamental challenge remains. The times when solar produces the most energy do not coincide with the times when electricity is needed the most. The general solution is to use batteries to store the excess electricity generated until 6:30 p.m. for later use, which significantly increases the actual cost of solar. Otherwise, grid operators have to turn natural gas power plants on and off to match the demand, which costs a huge amount of money too. Natural gas power plants' advantages, such as cheap upfront costs and fuel, and most importantly, their reliable flexibility to be used as a constant source of energy or backup supply, still make it a very attractive source of energy. Natural gas power plants are also actively replacing coal power plants as they edge out coal on both economic and environmental grounds. These are the reasons why natural gas remains instrumental, accounting for 7% of the new energy capacity to be installed in 2026. So, what is the conclusion? Based on current trend, the US will most likely not achieve the 2035 clean energy goal due to rapidly rising electricity demand from AI and data centers and the environmental limitations of wind and solar. In fact, the US Energy Information Administration even conservatively estimates that only 56% of clean energy ratio can be achieved by 2050. Nevertheless, given our society's increasing focus on sustainability issues, the nation will definitely be cleaner for the betterment of future generations. Thank you.